Hey everyone. Okay, so today we're going to be talking about the unit circle. So this is kind of like the start of trig. So the first thing we're going to do is I'm just going to kind of draw our unit circle. So here we go. So the reason we call it the unit circle, we had talked about this before with the complex numbers, is that this guy right here, this is the point 1, 0, which makes this the point, what? 0, negative 1. That point there makes this the point negative 1, 0. And it makes this the point 0, 1. Right? So it's a unit circle, and let's remember our equation for a circle. It's centered at the origin here. So the equation is going to be x squared plus y squared equals 1. You know, that's because the radius is 1, right? So remember we have x squared plus y squared equals r squared. So our r squared is 1, so we just put 1 here. So there are different measurements around the unit circle. So maybe you do or don't know, but there's this number, it's called pi. It's in your calculator. It's a number just like e that we've been working with. It's 3.14 159 ... For our class, you can just use 3.14 or just enter pi into your calculator. It doesn't really matter. So the distance around these, or this unit circle, we use pi to measure it. So if you're halfway in between this point here and this point here, so halfway, we call this distance pi over 4. All right, we'll call the distance pi over 4. So this is 45 degrees, right? Halfway. So this quadrant here is 90. So if it's 45 degrees, we're at pi over 4. And if we like drew a line straight down, right, it would be a triangle. And so what we can do is we could do the Pythagorean theorem if we wanted to, but I won't make us do it. And we'll get that this point is root 2 over 2, comma, root 2 over 2. Okay? So there's 45 degrees. So the next one we're going to have, I'm going to erase this 45 for us. So we're going to have this angle here. So it's going to be slightly less than pi over 4. It's going to be pi over 6. Okay. And this one's going to be root 3 over 2. And 1/2. Okay. And then the very last one we have is going to be this. This is going to be pi over 3. And this is going to be 1/2 root 3 over 2. So I know these two can get kind of tricky. That's okay. I'm going to erase this so not confusing. The way I remember it is it goes root 3, root 2, root 1 in the x value. So 3, 2, 1. That's how I remember that. So these are the distances around the unit circle. So this is 0 here. This is distance 0. And then this distance right here, when we're exactly at 90 degrees, well, that's pi over 2. What's great about being a circle is then it just repeats on the other side. You just have to look whether the x value is negative or positive. So if this is pi over 6, right, and this value is pi here, and this value is 3 pi over 2. Right, so we go 0, pi over 2, pi, 3 pi over 2. And then if we were to add pi over 2 again, we could get 2 pi, and then we could do it again. So if we add pi over 2 to 2 pi, what do we get? That's 5 pi over 2, 6 pi over 2, 7 pi over 2, and you can just keep going around and around and around. So anyway, this is pi here, and we know the little angle is pi over 6. So what's pi minus pi over 6? So pi minus pi over 6. Oh, that's just 5 pi over 6. Okay. And what's this one going to be? Well, this one's just going to be, okay, I have pi over 4, pi over 2. So this one's going to be 3 pi over 4. Okay. And then the last one we're going to get, let's see, what's this going to be? So I've added pi over 3. Now I add pi over 3 again. And I get 2 pi over 3. Okay. Like I was saying, it's symmetric, so it's really great. So this 5 pi over 6 is going to be the same as this pi over 6, except we have to look. We're over here now, so our x is negative, so we just make it negative root 3 over 2, comma 1/2. This guy right here, that's just going to be negative root 2 over 2, comma root 2 over 2. And this guy right here, I'm kind of running out of space on my whiteboard, but this guy right here is just going to be negative 1/2 root 3 over 2. Right? So there's the top half of the unit circle, and you could repeat it for the bottom half of the unit circle. For space sake, I'm only going to put the pi over 4 ones in. So this is pi, so this would be 5 pi over 4. Right, that's just pi plus pi over 4. And this would be, well, now let's think about it. Our x and y are both negative. So we have negative root 2 over 2, negative root 2 over 2. And this guy over here, so we have 3 pi over 2 plus pi over 4. So that's going to be 7 pi over 4. And this is going to be, let's see, our x is positive, so we're going to have root 2 over 2, but our y is still negative, so negative root 2 over 2. Okay, you can fill in the rest of these. I will say, you kind of have to memorize the unit circle. If you're going to take anything away from the trig section, there's like, I don't know, probably 2 main things. I will say 2. This is one of them, and the other one we'll do, I don't know, probably next week, or probably this week actually. Yeah, we'll do it this week. So this is really what you need to know. This is called the unit circle, okay? So I guess pause the video here and make sure you have this down. I'd fill in the other ones. You can also look up unit circle online and it will give it to you if you want to really fill it in, but you need to really memorize this. Okay. So I'm going to erase this, and we're going to talk about how do we tell a point is on the unit circle. So here we go. Let's see. So like, verify that 1/2 root 3 over 2 is on the unit circle. Well, that shouldn't be too hard for us. So remember the equation for the unit circle is x squared plus y squared equals 1, right? And so if we have x squared plus y squared equals 1, we have x and y. So we just plug it in. So we say, okay, I have 1/2 squared plus root 3 over 2 squared. Well, that's equal to, well, 1/2 squared, what is that? That's 1/4 plus root 3 over 2 squared. So you distribute it, right? And that root 3 squared is just 3. 2 squared is just 4. So you get 1/4 plus 3/4, which is equal to 1. So we're good. Okay? So that's how you verify something's on the unit circle. You could also do a slightly different approach. And it's like, oh, 1/2, we'll do it this way. So find x such that x 1/2 is on the unit circle, and I'll say in quadrant, the Q stands for quadrant, but I'll write it out for this time. Quadrant, we'll say 2, quadrant 2. So maybe you don't remember your geometry, that's totally fine. We'll go over it right now. So this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So it just kind of goes counterclockwise around. So I want to find the x that's in this quadrant here. Okay, so I'll go ahead and just do it over here. So we know we're on the unit circle again. So we have x squared plus 1/2 squared, because that's what we have. We know that's supposed to be equal to 1. So we just solve this. So we get x squared plus 1/4 equals 1, or x squared equals 3/4. So then we take the square root and we get x is equal to √3/2, but we have this plus or minus. So that's why we have to specify quadrant 2, right? So we want it to be in quadrant 2, which means what's our x value? Our x value is negative. So since we're in quadrant 2, x is going to equal negative √3/2. Okay. So there you go. That's how you like verify or check whether a point is on the unit circle. Okay. All right. So the next thing we have is just a bunch of vocab, to be completely honest. And the vocab is this. It's called a reference number and a terminal point. So the terminal point is probably easiest. So we have this terminal point here. And it's exactly the values that I had up on the unit circle. So it's like, if we have an example, and it was find the terminal point of, I don't know, let's say pi/2, pi/4, and pi/2, pi/4, and let's do 5π/6. Okay, well let's just draw a quick sketch of our unit circle. So what's it asking for us? It wants us to find the terminal point here, the terminal point here, and 5π/6 is over here. Okay. Well, I should know pi/2, just right off the bat, it's on the axis. So that's 1, 0. So that's one of my terminal points. Pi/4, well, we think about it, we're like, oh, pi/4, oh, that's halfway between 0 and pi/2, so that's the one where they're both the same. So my terminal point is √2/2, √2/2. And then 5π/6, you go, oh, I have no idea what 5π/6, but I do know what pi/6 is. So pi/6 is √3/2, 1/2. So I say, ooh, 5π/6, that's got to be negative √3/2, 1/2. Right? So that's my terminal point. So these are my answers here. It's just the values on the unit circle. Hopefully that makes sense. If you look up a unit circle and it has like pi/12, you don't have to know it. You just have to know the pi over 6, the pi over 3, the pi over 4, and the pi over 2's. And then all these endpoints. So pi, 3 pi over 2, and 0 or 2 pi. So that actually brings us nicely into our other one. It's called the reference number. So the reference number is this. It's the closest point to like the 180. So the reference number is going to be we'll say the closest point, or closest distance, we'll say distance. Closest distance to the start is how we'll do it. To, the start. So here we go. So the reference number here. So I guess we'll just do an example. So if I said find the reference number for, we'll do a couple of them. We'll do 7 pi over 6, pi over 4, 5 pi over 6. We'll do something crazy like, we'll do like 21 pi over 4 or something. Okay. So we're going to draw our unit circle here, I guess. So 7 pi over 6, well, let's think where that is. So 7 pi over 6 is bigger than pi, so it's probably going to be somewhere over here. This is 7 pi over 6. So rather than saying 7 pi over 6, we want the closest to the start, which means we're going to go around this way, right? So if we go around this way, what are we doing? We're going to go from 0 basically to pi, right? Everyone see that? We're going to go from 0 to pi. We're just going to go backwards, right? So we're going to go from 0 to pi, but we're going backwards. So really, how far away from pi are we? Well, pi is the same thing as pi is equal to 6 pi over 6, right? Because we're at 7 pi over 6. So if we have 7 pi over 6, so if we start at here, at 6 pi over 6, we want to subtract off, we want to know how far away we are from 7 pi over 6. So what do we get? Negative pi over 6, right? That's how far away we are. So 7 pi over 6 and negative, that's not right. Sorry. Scratch that. Sorry, we're negative pi over 6 away. So actually, I should have left that up. We're negative pi over 6 away from pi. So then we do pi over 6 minus pi, and we get negative 5 pi over 6. I'm going to do another example because that was really bad. So let's think about this again. So if we're at 7 pi over 6, we think about, oh, how far away are we from pi? Well, we're pi over 6 away, right? So if we're pi over 6 away from pi, then I want to know how far I have to travel. Well, that's the same thing as pi over 6 minus pi. So I need to travel minus 5 pi over 6 to get to this point. Okay. Let's move on to the next one. So pi over 4. So if we have pi over 4, here we go. Here's our unit circle. Pi over 4 is an easy one. So here we go. If we're at pi over 4, what's the farthest away I am? Well, I'm just pi over 4. So the reference number for pi over 4 is just pi over 4. It's not bad, right? Same thing here, because you're always going from this point here. If I'm at 5 pi over 6, well, where am I at? 5 pi over 6 is over here. So how far away am I from this, from the start here? Well, I'm just 5 pi over 6 away, right? So that's still the answer for that one, right? Now the next one, I think, was 21 pi over 4. So we should figure out what that is, 21 pi over 4. So if I'm at 21 pi over 4, so let's see, 21 pi over 4. Well, that's the same thing as 20 pi over 4 plus pi over 4. So that's the same thing as what? 5 pi plus pi over 4. So 5 pi, let's do it. So remember, every 180 is 1 pi. So we're going to go 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. So I've gone 5 pi. I'm right here. Now I need to go pi over 4 more. So I want that angle. Okay, so this is what I was talking about before. So if we were to go all the way around, what would this be? So this is pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Well, this would be 5 pi over 4. Well, that's not going to work because there's a shorter distance this way. So if I'm 5 pi over 4 around, I want to know how far I am from the start. And remember, this start is 2 pi, right? So if the start is 0 or 2 pi, I'm going to have 2 pi minus 5 pi over 4. So that's the same thing as 8 pi over 4 minus 5 pi over 4, which is equal to 3 pi over 4. But did I go counterclockwise? No. I went the other way, so I have to make this a negative. Okay? Okay, so that's reference number. Those are just kind of some terminologies that you really don't have to know, but you should know them for the homework, I guess. But like, I won't test you on them personally. Okay. So the next part has to actually do with trig. So there's this cool thing. When we're doing a triangle, we have this thing, this is some value x, this is some value y, and this is going to be 1 if we're on our unit circle, right? So this is what it is. That's how we get x squared plus y squared is 1, right? So this is just a triangle. I can draw a little mini guy right here. This is just our triangle here. This is some value x, that's some value y. That's always going to be 1. So I just blew up the triangle right here. So sometimes we know like one of these values, but we only know 1, and then we know like this angle here. We don't know the other sides, so we want a way to be able to figure out what the other sides are. And the way we do that are these trig functions. So I'm going to write down what the trig functions are. So the trig functions are this. So we have cosine and theta, that's that guy, is going to be used for angle. So we have cosine theta, we have a sine theta, we have tangent theta, these are really the important ones. You can know the other ones too. Secant theta, cosecant theta, and cotangent theta. Okay, so cosine theta, this is just your x value. Sine theta is just your y value. Tangent theta, so tangent theta is sine theta over cosine theta. So what's that mean? This is just y over x. Secant theta, that's 1 over cosine theta. So that's 1 over x. Cosecant theta is 1 over sine theta. So that's 1 over y. And cotangent theta is 1 over tangent theta. So that means 1 over sine over cosine, which just means you flip them. So it's cosine theta over sine theta. So this is x over y. So maybe some of you guys remember. SOHCAHTOA. So this is sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Well, let's draw a triangle again. Make sure it all makes sense. X, y, call it 1. So cosine is, let's start with sine since it's SOHCAHTOA. So sine is opposite over hypotenuse. So here's my theta. So opposite y over 1. Yeah, it's just y. Cosine is x over 1. So just x. And you can verify it, that they're all the same. Just what you learned with SOHCAHTOA. So however you want to remember it is fine by me. But that does help us with our unit circle, right? So in our unit circle, for example, if I'm here, my unit circle, we'll do some easy ones. So remember, this is 0 or 2 pi. This is 3 pi over 2. Or the next one you would get is 7 pi over 2. This is pi or 3 pi. This is pi over 2, or what's the next one? So this is 6 pi over 2. No, this is 5 pi over 2. Also no. 4 pi over 2, 5 pi. 5 pi over 2. Yeah, I don't know why that was really hard for me. Alright, yeah, 5 pi over 2. So here we go. So this means what? This means exactly this. Cosine of 0, so to remember what this point was, this is the point 1, 0. So cosine of 0, right, which is the same thing of cosine of 2 pi, it's one and the same. Well, cosine is the x value, so cosine of 0 or cosine of 2 pi is 1. Sine of 0 or sine of 2 pi, that's equal to the y value, so that's 0. Okay. You can do this one too if you wanted. So this is the point 0, 1. So this means that cosine of pi over 2 is the x value here. So it's just 0. Sine of pi over 2 is just the y value. So it's just equal to, okay? And you can do this all the way around. So test. Okay. So cosine of pi over 4 is equal to what? Pause, think about it. Tick, 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 tick. So I'm at pi over 4, right? I'm here. We know this point is root 2 over 2, root 2 over 2. So I say, ooh, it's the x value, so it's root 2 over 2. So those are our trig functions, okay? So because there are trig functions, we gotta talk about like the domain of our trig functions and stuff like that. So the domain of our trig functions, so for, I guess I'll put it in a chart. So if you have sine and cosine, you can plug any number you want. So it's all real numbers. Okay? But if you have tangent and secant, well, let's think about this. Tangent is sine over cosine, and which means we have a fraction, so we can't divide by 0. Right? So since we can't divide by 0, and cosine's on the bottom, we need to think, oh, where is cosine 0? Well, cosine is 0 at pi over 2, at 3 pi over 2, at 5 pi over 2, right? And so on. You can keep going. So the fancy way of writing this is pi over 2 plus, oh look, we're adding pi every time, so you say plus n pi. So it's everywhere except pi over 2 plus n pi over 2, plus n pi. So then the other ones is cotangent and cosecant. So this is where sine's on the bottom, right? So sine is 0 at 0 and pi, and 2 pi. So the way you say this is everywhere. Except pi plus n pi, where n can be any integer it wants to be. So that's the domain of these trig functions. So there's really just like one more thing to go over, and they're called identities. These are identities. So let's think about our unit circle one more time. So we have x squared plus y squared equals 1. But remember what x is? X was cosine. So that's the same thing as saying cosine squared theta. And y is sine plus sine squared theta is equal to 1. This guy is like ultra important. You will forever ingrain this in your head, just because you have to. So the other identities you can get from this are this. So tangent squared theta plus 1 is equal to secant squared theta. Okay? So that's another one you could get. And the last one is 1 plus cotangent theta, cotangent squared theta, is equal to cosecant squared theta. Right? These are very similar. Right? So those are called the Pythagorean identities, because you use the Pythagorean theorem to get them, right? That being said, you can also like write, now you can like rearrange these. So if I rearrange this guy, I get that 1 minus cosine squared theta is sine squared theta, which means I can take the square root, which means the square root 1 minus cosine squared theta is equal to sine theta. Okay? You're going to have to do a lot of rearranging. These three are going to be your best friend. you can get any other trig identity that you could ever think of from these three right here. Okay? Alright, I think that's it. The next lecture, we'll be talking about how to graph these guys. So just practice, get used to them. I will say, you should put your calculator in radians mode. So here you go. If you have this guy right here, right, you hit this degree button and make sure that thing says rad. That's radians. That's what like pi over 4 is, pi over 2. If I said find sine of 45 degrees, then you'd go back to degrees. But we're going to be sticking in radians because that's what everyone uses. So you go to rad, you hit enter, and now you see the little rad button here. Okay, that's it, and I'll see you next time.